All right, so let's talk about testing. Make some notes here. So we've been kind of glossing over tests so far in the program, but here we're going to talk a little bit more deeply about just practically how tests are written in like a real dev team, who writes tests, when and why you write tests, different kinds of tests. There's going to be a little bit of like practical me showing you how to write a couple tests, but a lot of this is I just kind of want to talk about the general testing ecosystem and environment and just the culture. Because a lot of employers that you'll be talking with will expect you to have some experience with tests. So it's good if you can just kind of talk the talk about the different kinds of tests and say what you've done, what you haven't. This is more and more becoming, I don't want to say a requirement, but it's definitely something that employers are looking for as they're hiring even junior developers. So I want to start off.
Raphael, can I ask you a quick question? I've heard like from people that if you are applying for a job and you include tests in like your challenge that they have you complete, that kind of like pushes you to the front of the line. Do you feel like that's true?
For sure, 100%. If I'm grading code submissions from applicants, for one thing, the ones that have tests included are going to be easier to grade, but it also just reflects very well on the applicant. Just do they know how to write tests? They appreciate the value. It's kind of nonsense though, because like for those kinds of coding assignments, they're going to be like, oh, build like a full stack web application in 2.5 hours. And like, if you're actually trying to keep under the time limit, like you're not going to have time to write tests, but the successful applicants usually take a lot more time than is recommended for those exercises. So do write tests, and interviewers will be happy to see them. So first question I want to answer, who is writing the tests? So there are kind of two ways that this issue gets addressed. Either developers test their own code. So I think this is pretty great because it makes the developers more responsible for making sure their code actually works and they're more in touch with the requirements, the business requirements for the application. The other alternative is you have a dedicated testing team. So this is nice because it allows efficient division of labor. We can see in some cases you can hire testers that aren't even engineers, or they might not even know the same programming languages that the app is built in. In general, though, I don't like having a dedicated testing team. I think it makes the engineers, the developers, kind of care less about the quality of their own code because it's like someone else's responsibility to actually test it. So I've generally preferred working on teams where developers test their own code. I don't think anyone understands my code better than I do, so I should test my own code. And also, just for the rest of this lecture, I'm going to be assuming that you are writing tests for your own code, because this would be a very short lecture if I just told you it was someone else's job. So also feel free to interrupt me and ask questions about any of these questions, but if not, I'm just going to tell you my thoughts and opinions about testing. So now you might also wonder, why write tests? So there are actually a lot of answers to this question. Some of them are not obvious. Why don't we just get some people shouting out some thoughts? Why should you write tests?
To make sure all your dependencies and APIs that you're calling out to work properly in a big project.
So yeah, make sure stuff works. You're expecting to give things certain inputs, they should give you certain outputs in order for the whole application to function. Write tests just to make sure things do what you think they should be doing. Why else are tests good to write?
Otherwise, you just console log everything a million times until you're like, yeah, that probably works.
Yep. So it can be a cleaner way of even just developing instead of just putting console logs all through the feature as you're building it. You write a test as you're building a feature, and then that test is going to call the function and log the output. So you don't have to like litter all your logging code in the application itself. You put it in the test, and then when you're done, you have a nice test for your feature.
Will it make it easier to debug too?
So yeah, it makes it easier to debug. So more specifically, having tests help you get confidence in refactoring old code. So, you might have a piece of code that was written like 10 years ago and it's impossible to read because it's just so ancient, but it works. And so nobody wants to touch it. That's a kind of bad situation to be in. Ideally, you should have tests for the code so you can run the tests and say like, hey, I've made all these changes to the code, but it still passes the tests. So like at a high level, it still works the same way. So my changes are good. So as long as you can change the code and still pass all the same tests, you should feel confident that your refactor was not problematic. Here's one you might not be familiar with, helps enable continuous delivery. The idea here is that you want to deploy the application as frequently as possible. So commonly an application would, be tested like once a quarter. And then after all the tests pass manually, then you deploy it carefully with everyone watching. But if you have a lot of automated tests that can give you a lot of confidence that your application is running reliably, then you don't need to manually test it. You can just automatically deploy new versions like every week. So let's see, tests prevent bugs from reoccurring. So it's not possible to write a test to prevent every possible bug that has never occurred. But at the very least, if you suffer from a bug once, that should be the last time you suffer from it. Because it's certainly more embarrassing for your company if you suffer from the same bug multiple times, as opposed to dealing with new bugs over time. So if you deal with a specific bug, you will often write a test just to make sure that that one bug doesn't happen again. And then lastly, this is honestly, I think, one of the more important values of writing tests. And this is something that I didn't really appreciate fully until I want to say the past couple of years. I've been developing for like a decade now, and people always tell you about the importance of tests. But this isn't really something I fully appreciate until recently. But that tests serve as verifiable documentation for the code. So this is a problem that I've had in a lot of places that I've worked at, where they have this huge code base and I'm trying to figure it out. And it's not even just one application, but like multiple applications that interact with each other. And I'm just trying to figure out like, what happens when I call these functions? Like, is that going to break everything, or is it going to, give me an interesting response that helps me learn about the code? Like, how does all this stuff work? And maybe reading the code doesn't help much because it's like really messy code. So they often have documentation, just written down like in README files or whatever. But when I look at those documentation files, I'll see that they were last updated like 8 months ago, and the project is only a year old. So I'm not very confident that the documentation is accurate. So oftentimes the documentation is like completely out of date and totally inaccurate. That's bad. Sometimes it's only like 20% inaccurate, and that's even worse because you'll depend on it and it'll let you down. So in contrast, tests are really nice because if you read a test that says like, hey, if you call this function with X input and it'll return Y output, you don't have to just trust what you read. You can run the test and it'll tell you like, yeah, this is actually how the function works. This is not out of date documentation, but it is like in fact correct. You're reading like accurate documentation of how this function works. So this is like, regarding tests, one of the best pro tips I can give you as an experienced developer is if you're being onboarded to a new project and you're just like totally overwhelmed at like the size and scale of everything, look at the tests. The tests are probably going to be more useful, more informative to you than reading any documentation they have, and definitely better than reading the actual code, because they're going to describe, how the functions work, what you put into them, what you get out of them, but not even all the functions in the application, because nobody has time to write tests for every single function in an application. They're going to only have tests for the important code. The things that they made time to write tests for. So reading the tests in a modern application, I think, is a really quick way to get up to speed and figure out like what matters here, what's important, what do I need to understand. All right, so there are several different types of testing. So really lots of different types of testing, lots of testing frameworks, lots of different opinions about what testing even is and how to do it. So I could definitely teach an entire boot camp about testing. So we're just going to kind of cover the basics here. But can anyone just shout out, has anyone heard of different types of tests?
Jest and Jasmine.
Okay, so those are specific tools that are used for running tests. We're going to talk about those in a moment, but they can run different kinds of tests. So can we think about a different way we could answer that question maybe?
A unit test?
Yeah, so that's one type of test. Unit tests. Let's get a couple other examples.
I don't know what it's called, but basically like using a website. So for front end, they would test like whether things work. Usually it's like a person, but I guess they've done automated versions.
You're talking like automating a browser to sort of like click on buttons and navigate through the front end of the website.
Yeah.
So that's called a functional test, because you're testing if the website functions just in general, or sometimes called an end-to-end test, meaning that the whole application works from the front end to the back end and then back to the front end again. So that's another important type of test. So unit tests being the smallest one, those end-to-end tests are being the biggest one. There's something else that's kind of in the middle here. I don't know if anyone's heard of this. If not, I'll just give it to you.
Integration testing,
Say again?
integration testing.
Yep. Integration testing. So these are the three kinds of tests that we're going to talk about this morning. So for a unit test tests a unit. It's the smallest testable piece of your application. So typically this is a single function. Sometimes people interpret a unit test as being a test for a single class, which would certainly be much bigger than a single function. I'm not going to split hairs about the definition here. So to make your unit testing easy, you want to have functions that just take inputs and return outputs, but to have no side effects. So if the function doesn't depend on the entire rest of your application, it's much easier to verify that it's working correctly. But most importantly, unit tests should be fast. So people will argue like all day about what does and does not constitute a unit test. Like if you're testing this and that, it is a unit test. If you do this thing, then it's not a unit test. I don't really care about this conversation. I think it's really pedantic and doesn't provide value for the most part. What I think does matter is that your unit tests should be fast. If you're just testing a function that's just input and output, and you want to make sure that it returns the value you think it should, there's no reason why that should take you like even a whole millisecond to run that function. So you should have like a suite of 1,000 unit tests, that runs like in seconds, basically. If you find that you need to test something that you can't do in a millisecond or two, maybe it doesn't belong with your unit tests. So common tools that you'll use for unit testing, or that you may have heard about for unit testing in JavaScript. Traditionally, there's all the hot beverage frameworks. So like Jasmine, Mocha, Chai. These are all like basically the same. This is just like one of those weird quirks of the JavaScript ecosystem where one person makes a framework and someone else is like, I'm going to make a better version of that framework. And so they give it like a similar kind of name. So I think Jasmine came first, it's like Jasmine tea. So people made a bunch of other testing frameworks named after hot beverages. I think it's kind of funny. But today we're going to be using one that kind of breaks this trend. We're going to use Jest. So Jest is also very similar to Chai, Mocha, and Jasmine. And like, honestly, if you showed me code snippets from each of these 4 libraries, it would probably take me like 10 or 15 seconds to figure out which one was which. Like they're all very similar. JavaScript developers like to write their tests the same way, no matter what tool they're using. But Jest is built into Create React App, so that's very convenient. I appreciate the convenience of having it built in over any of the relative advantages of these libraries. All right, so now let's take a minute and actually write a unit test using Jest. So let me open up my news site real quick. Apparently I have something else running on port 3000, can't quite find it. So we're running this on 3001, shouldn't be any issue. Assuming it opens eventually. There we go. Okay, so here's my news site. So let's talk about testing a little bit. Okay. So you might remember previously I was, whatchamacallit? Okay, so looking at my article component here, I do a little bit of calculation to get the time dot to locale date string. So we have to get the time, the timestamp from the API, and we do a little bit of calculations here, create a new date, return a new date object to locale time string, locale date string, sorry. And so then I can just use that in my template, instead of just using time dot to locale date string, we can just call.
Wait, Raphael, can I just ask real quick, just for like people who are following along, in our version for like the 4th version, this is not article.js, it would be article teaser. Is that correct? That we would do these changes in?
I'm not 100% sure. My version might be organized slightly different than yours. So I'd have to look at, wherever you're doing the calculation. Although it's also
Yeah, it's article
possible.
teaser from, sorry, but yeah, it looks like in ours, we are not using article.js at all, and it's an article teaser. So just if anyone's following along, if
Yep.
that helps.
So in my version, I'm actually using this code in both article and article teaser, which makes it an even better idea for me to put this into its own function instead of just duplicating the logic right in the render. And yeah, I guess when you move to using the Hacker News API, it's not so obvious why you need the article.js component itself. So I kind of like made it useful, but you could probably build a useful news site without this particular component. Let's see, so we've got our function format time takes in time. Oh, whoopsies. So that's the date there. That's not quite correct. So yeah, I'm using my helper method format time, passing in the time here. So I'm not sure if this is working correctly on the page right now. I might have to debug this in a second. The important part is here, I have refactored this function. So it's now just a single function that takes some input and returns a value. I have all the calculations included here inside of this function. And then I'm exporting it so that my testing file is able to make use of this. So now in my app.test.js, sorry, this is a lot. I should probably make a new test file here. So we're going to import format time. So I want to test this out. Now, instead of just like testing it, we've got to add some structure to our tests. So this is a function that Jest provides. This is defined by default by Jest, called describe. This doesn't actually really do anything, but this just lets us organize our tests into different blocks. So I'll show you that in a second here. I'm going to describe, and then I put a string kind of describing what I'm about to test. We're going to describe the format time function. And then a nested callback here. So yeah, the describe block is saying that this is like one section of my tests. I have an entire section of my tests about the format time function. And then inside of here, I'll have another describe block. Now, then this describe block is saying there's another section of my tests when the format time function gets valid input. I'm gonna write those tests in here. Of another block of tests when it is passed invalid input. And then for the actual tests, we're going to declare that with a function called it. Now I know this looks really strange up front. When I run the code, you're going to see this kind of makes sense. Here I'm going to say what it should do. Put another function in here. So let's see here. So this should be a valid Unix timestamp. So we use expect to say that this is an expectation, this is an assertion, this is where I need to check that my app does something specific. I'm going to say it should be, now this is definitely incorrect, but I'm just going to run it, see what it does so far. This should be today. So I didn't want to run this test right now. I just renamed it real quick. But anyway, so right now there's only one test file in my whole application. I got this unit.test.js. Because it has the name .test.js in it, create React app is automatically configured to look for it. So I'm going to npm test, and this should automatically find all the tests in my React application. And it failed. That's definitely what I was expecting. Okay, so I was expecting today, the string today, but what I received was this 4/5/22. Now look at the explanation it gives me for the failure. The format time function, when passed valid input, should return a legible date string. So this is why we have these describe blocks and why we structure it this way, so that whatever it is that breaks in our application, when that test fails, we can get legible output showing like which subset of the tests failed, and it'll read like English telling us what's wrong. So now that I know what it's supposed to be, let's actually change this. 4/5/2022. And so now we see that all the tests have passed. On that note, I apologize, but I really need to use the restroom. So I'm going to run off for like a quick 3-minute break and do that. Think of questions that you have in that time, and I'll be right back. All right, I'm back now. Very sorry for that interruption just now. But so in a nutshell, this is what a unit test looks like. Andrew, a question?
Yeah, could you put the expects like earlier in the thing to see what happens if it fails earlier?
Like where? How do you mean?
Like if line 6 got switched with like line 4, is it gonna? I just want to see what happens because like it's like nested in like it's like nested deep right now. I just want to see what happens.
I mean, nothing good is going to happen. The format of these tests, you're not supposed to put anything interesting inside of the describe block, except for other describe blocks or an it block. I guess that did actually work, but I was not expecting it to. Generally speaking, the only thing that you should have inside of a describe block is another describe block or an it block. There shouldn't be like custom code. All the like custom code for checking your application should be inside of the it block. So I might run more code here. Got another question?
Yeah, I'm a little confused. And why not just combine lines 3 and 4? So that it can just say the format time function, comma, when passed valid input. Like, why are they on different lines?
Because it also might be passed invalid input.
Oh, I see. The indentation matters here.
Not indentation literally, because it's JavaScript, but yeah, the braces, what's inside of what, it matters. When pass invalid input, return, so format null should be, oops, not a valid date, but that's not what we're going to get. So I've got one test passed. The format time function when passed valid input should return a legible date string. It does do that. But the format time function when passed invalid input should return a legible error, but it doesn't. So if you nest these correctly, then you'll get very English readable output when your tests fail. Because yeah, here this told me December 31st, 1969, which I know that like Unix time starts in 1970. So this tells me that an error was made. Generally, did you have a hand up?
I think I completely missed it, but where are the keywords describe it coming from? Are those coming from React or is that like from a library?
These are coming from Jest. So that's a very good question because they're not defined in this file. And that's very strange. Generally, you will almost never like be working with variables that are not either native to the language or imported explicitly in the file. But this is how Jest works because I'm not actually running this function myself. Like I never have to type, node unit.test.js, whatever. I'm just invoking Jest and then Jest runs these functions for me. And when Jest runs these functions, it's going to make sure that there is a globally defined function called describe and it and expect, or maybe that's built into JavaScript actually. No, this has got to be a special Jest specific expect. A couple other hands up.
Sorry,
Yeah.
I had another one. Sorry, Andrew. Just to kind of clarify, we are testing the format time from article.js to see if like the output is exactly what we expected using the keyword to be.
Yeah,
Okay.
that's correct. And there are other like checks that we could do here other than to be. This is going to check that it's exactly this value, but you can check like dot should contain or be equal to, or is less than. You know, there are other kind of comparisons, but this is just the simplest one. Andrew, did you have your hand up?
Yeah, how did you install Jest? Is it in node modules?
It is, but I didn't install it. It just comes with create React app. Like, you know, you do npx create React app, whatever, and then you watch bars fill for like 10 minutes. Like Jest is one of the many libraries that gets installed when you do create React app. So I'm looking here, testing library Jest DOM. That was already in the dependencies. I didn't have to add that. And the ESLint is already configured to understand Jest. So yeah, create React app is pre-configured to use Jest, which is pretty nice because it can be kind of a hassle to set up the testing environment on your own. What other questions do we have? Wow.
So I'm so I'm wondering, like, how does this Jest testing like collaborating with your main web page? Like when there is a invalid value put in there, will the website still run, or that testing function will actually stop the website from running?
So these tests don't run as part of your actual application running. They only run when I manually invoke them using npm test. So it's just for me, whenever I want to know, it's for me to know if my application is functioning correctly according to how I've defined that in my tests. So these aren't like the validators for Django, where the validators will actually throw errors when your application is running if something isn't the way it should be. This is not that. These tests will not throw errors while your application is running. They just tell you while you're developing if you built a new feature that breaks an old feature or something like that.
Oh, that makes sense. Thank you.
Mm-hmm. So one more thing I want to talk about a little bit briefly. I don't know how much time. I'm not going to demo this too deep, but so I mentioned that unit tests are supposed to be fast, but sometimes you need to test functions that just aren't fast. Like you need to do a database query that takes a half a second, or send an API request that takes a little bit of time. And you want to make your tests more reliable instead of reaching out to this other component that fails randomly sometimes. And you also want your tests to be faster. So one way we can achieve that is with Jest mocks. So a mock is just like a fake function. A mock is just a fake whatever. So we're going to create a fake version of a function so that instead of calling the real Axios, we call a fake version of Axios that just returns some hard-coded value. So it doesn't tell us if our API requests are actually working, but it lets us test other functions that use the API without actually sending API requests. So it's a little bit faster. I'm going to see if I can whip up a real quick example of that for you. So let's say, so jest.fn is just creating a generic function that does basically nothing at this point. But all of these Jest functions have methods on them that we can call, such as mock resolved value. So here I basically just created a fake function using Jest. And this is saying that whenever it gets called, it should just hard code this return value, a promise that resolves to data hello world. So, if I want to test it, so I said that this fake function should resolve a value instead of return a value. So this is going to be an async function. Await our fake get data, expect value to be just that object that we hard coded, because that's what we said the mock should return. And it looks like that did not actually work. It is also not working for some reason. I swear I demoed this morning and it was totally working. Seem to have some problem with the mock here. It's supposed to return just exactly this value because I've told it to. And then I should be able to plug that into the rest of my code. So I'm using this fake API instead of the real API. Looks like it's not quite working, right? But honestly, this brings me to my next point of I really don't like mocks in general. They are a reasonably popular feature in modern testing libraries, and there's a decent chance that whatever team you end up working on is going to have like mock functions in their tests. But in my opinion, it's just always kind of a mistake. So mock functions are probably going to be more complicated than any of your other test code, for one thing, because they're like replacing another module, replacing another function that's already being called with like a different value. So there's a lot of like automatic magic happening under the hood with these mock functions. But the problem with that is that you don't write tests for your tests. So if there are bugs in your tests, it's very hard to catch them. So ideally, your test code should be as simple as possible, just importing and calling functions from your application. But when your mock functions are complicated themselves, I just think that's really dangerous. You end up like, there's just a danger that you might have bugs in your code and you'll get false positives on your tests and not know it, or like your tests will fail for no reason. And also just you need to update the mocks every time you update your application code. Like if I have a mock that just returns success true in response to an API request, but then I change my API, so instead of returning success true, it's like data true, then I need to update all the mocks where I'm faking that API. So in my opinion, using mocks, you spend a lot of time and effort on testing something that is not your actual application, and it helps your tests run fast, but it doesn't actually give you more confidence that your application is working correctly because you're testing not your application. It's this fake function that you made that just like pretends to be part of your application. And they're just generally more complex than the other features in your testing library. So yeah, you can read through the documentation here. There's a lot of different types of mocks that you can use, different ways you can use them. I just showed you the most basic way. And even still, I guess I'd have to debug it a little bit more to get it working. Sorry, we only have a few minutes before our guest speaker this morning. So So aside from me not getting this mock to work quite how I wanted, that's really all I have to tell you about unit testing. We're going to have to continue this lecture this afternoon after our guest speaker. So I'm sorry. I'm going to say at 1:30, I'm going to keep talking about testing so we can cover integration testing and then lastly, functional testing using Puppeteer. So that's going to be part of our homework for tonight. And then couple other topics that I want to just chat about to end this conversation. But yeah, so we're gonna have to pause here, switch gears for our guest speaker. And then this afternoon, we'll finish up talking about testing. In the last 2 minutes we have here before our speaker shows up, does anybody have any questions about what I've shown us all so far?
And just as a small request for our guest speakers, please do have your cameras on, just to kind of give your full attention to our guest speakers, if you can. Thanks.
Yeah, totally. Thank you, Ankur. I understand that people are tired, so I don't get offended if y'all have your cameras off. Sometimes I definitely prefer it. I like seeing your faces, but certainly for the guest speakers, please be respectful, put your cameras on, let them know that you're here, be engaged.
And also another small request. So I know, again, the Zoom chat's nice, casual chat usually, but yeah, for our guest speakers, they sometimes can get distracted by it. So please try to limit the casual chat and use it for questions for the guest speakers in case they are monitoring it.
Yeah, that too. Thank you, Ankur. All right, and with that, I'm going to stop recording.